All right, today we are going to talk about Investigation 1.4 from the Comparing Bits and Pieces book. This is about finding fractional parts of a number. We are going to take a look at this first off by comparing two different statements that people have made regarding the fundraising goals from problem 1.1. What this says is that for every $60 that sixth grade plans to raise, okay, so $60 for sixth graders, that seventh graders will plan to raise 90. Okay, and this is a for every statement, so our ratio would be a 60 to 90 ratio or a 60 over 90 ratio. Okay, or we could even write 60 to 90. All right, so we have three different ratios that are comparing here. And then Kimmy says when the sixth graders met their goal, they will have raised 2/3 of the seventh grade goal. So she's saying that sixth grade is going to raise 2/3. So we have a couple of ways that we can show this. The first way would to look at the comparison between 60 and 90. So because this one involves the fraction 2/3, I'm going to take this form of my ratio from Ben's statement to see if that does in fact equal 2/3. So using our equivalent fraction method from yesterday, we want this to be turned in to a 60 over 90. So first thing I'm going to do is I'm going to see what number I can multiply these by. Okay, so we're going to make 2/3 larger and see if we can turn it into 60 times 90. So the first thing I'm going to do is I'm going to multiply both of those by 3. Okay, what we do to the numerator, we have to do to the denominator. So that gives me the fraction 6 over 9. And then if I look real carefully, these two are very similar in the fact that 60 is 10 times larger than 6 and 90 is 10 times larger than 9. So what that means is in order to get to 60 over 90, I'm going to multiply each one of those by 10. Okay, and that would give us 60 over 90. So 2/3 is the equivalent of the ratio 60 to 90 or 60 to 90 up here. Okay, the other way would be to reduce our original ratio of 60 to 90 using division. Okay, and since both of these end in a 0, I know I can divide both by 10. Okay, so we start with what we know, and that would give me 6 over 9. And now I'm going to look for a common factor that both of those can be divided by. So I know that 6 is an even number, and it would be that the factors of 6 are 1, 2, 3, and 6, and that the factors of 9 are 1, 3, and 9. So I know because of that their common factor is 3. So I can divide both of those by 3, and then I get the equivalent fraction 6 divided by 3. My new numerator is 2, and 9 divided by 3, is also 3, and so it also equals 2/3. So both of these are true statements. Okay, which means if we put out a thermometer that when the sixth graders have earned 2 times 60, the seventh graders will have earned the equivalent of 2 times 90. Those work when comparing. So let's take a look at page 21 in our book, and this really is going to be answering question A right here, where it says, how can you tell whether the sixth graders have raised the same amount each day, and explain? Well, before you come to class tomorrow, you will have to have question A answered, but we are going to take a look at page 21 and we're going to describe what we see here. So what I'm going to do is I am simply going to put a dot at the top of each bar, okay? Because if they're raising the same amount each day, we should see the same increments, okay? And then what I'm going to do is I'm going to use my line tool, and I am going to drag a line. Whoa, that's kind of a big line. We're going to undo that, and I will adjust the thickness of my line to something a little bit smaller. Okay, so if I start here and I drag this across, okay, my increments should go up by the same amount every day. Okay, so if I come out here, all right, and then I'll come over here, and I'll come up here, and I'll just keep making the lines extend out. Okay, and then I'm going to take a look at the distance between the lines. Okay, so from day 0, which we would assume would be nothing, they raise this amount. Okay, so if they raise the same amount each day, we would have the same distance between our lines. So I drew a line here. I'm going to change that real quick and make it a straight line using my line tool. Okay, and we'll make it like bright. What do we think here? Let's go with purple for all you K-State fans out there. All right, so I'm going to drag a line. Whoops, not that line. Go back to my line. Okay, and I'm going to drag from the top to the bottom. Okay, now this distance is what they raised on day 2. So when I go to day 4, they should raise the same amount. But notice how this line is larger. So we can really say that they didn't raise the same amount because the distance between our lines is different. Okay? See how it's still different? They still didn't raise the same amount. They raised less money between days 2 and 3 than they did between, or days 2 and 4 than they did between days 4 and 6. And if I go up here, I can still compare them. So to compare, whoops, now I'm moving the whole picture. To compare how much they raised, we would compare the distance between our lines at every stage of the game. Excuse me. So looking at these, we can tell that each day is different. Okay, they did not raise the same amount. Did not raise the same amount every day. Because if they had, then the distance between the lines should have been equal. Okay, the black line should have been able to fill the gap in all 3 of those. All right, so again, this is using equivalence to help us find our answers. All right, so going over here to question A, how can you tell whether the 6th graders have raised the same amount each day? Because the distance of their lines, excuse me, because the height of the bars each day should go up by the same amount. If it's not, then they're raising different amounts of money. So go ahead and make sure that you come to class with question A done. I would make sure as well that you can understand this whole concept of how to tell that each day they've raised a different amount. And I know these are counting in increments of 2. So really what they should have raised if they're raising the same amount each day is this amount right here, which would be half, or what's the equivalent of day 1. Okay? So go ahead and watch it a few times. I know it's a little confusing and I apologize, but again, we're just working with equivalent fractions. I can tell that these are not the same size. Each one of these little pieces here that it grew is not the same size. So therefore it's not going to be an equal amount.